All right, guys, getting into Chapter 4, the wonderful world of triangles. So to start things out, we're just going over some very basic ideas of triangles. Guys, as always, if you are not filling out my guided notes, if you did not print these and you are taking your own notes, you need to make sure you're writing down all the important stuff. So these bullet points, need to get those written down. But here's a couple things that are going on. We are looking at mostly just classifying triangles by their angles and by their sides. We're going to talk about both those things. So if all three of the angles in the triangle are acute, in other words, less than 90, then overall the triangle is an acute triangle. If they are all congruent and acute, which would mean they're all 60, so this would be what we call a 60-60-60 triangle, then we call it an equiangular triangle. If one of the angles is obtuse, then we have an obtuse triangle. Side note, it's not possible to have more than one obtuse angle in a triangle, or it would not be a triangle. So you can only have one, but so if you do get an obtuse angle, then it's an obtuse triangle. Same thing with a right angle, then it becomes a right triangle. So those are just a few names that we're going to look at as far as the angles are concerned. So here's just one that couple that they did for you. So as I look at letter A, I can see, first of all, that they're all acute. So I do know this is an acute triangle, but can we go even further to say that it's equiangular? We can see by the marks that they are all congruent. So these are all 60-degree angles, which means this is an equiangular triangle. So it's not wrong to say that it's acute. It's just that when you can be more specific, like equiangular is just a more specific type of an acute triangle, then we want to be as specific as possible. Okay, so we want to give it the name of equiangular when that's available, instead of just saying it's acute. Acute is a little more of a broader term. As we look at this one, we saw that there was one angle that was obtuse, right, bigger than 90 degrees. Therefore, this was an obtuse triangle. So that's how we'd classify it. And here's the third one. You can see the 90-degree right angle. So as soon as you see that right angle, we're going to call it a right triangle. So here's a couple we can try on our own. Guys, again, if you are taking your own notes on this, you do need to write down the examples that we just discussed. So make sure you write down those guys and put them into your notes. And then we're also going to try a couple of these together. So if you're taking your own notes right now, this is a good time to pause and write these three down and give them a try on your own, and then fill them out with me as I go through them. So real simple on these guys. As soon as I see the 90 degrees, we would automatically label this as a right triangle. Right here I get the angle that is obtuse. So this would be an obtuse triangle. And then right here I have a 60-60-60. Again, guys, this is considered an acute triangle. But when you see the 60-60-60 going on, we want to give it the special type of an acute triangle that it really is. So it's not wrong to say that it's acute, but because we can be more specific and go as far as saying it is equiangular, then we want to go that far. So equiangular. Guys, one thing I want you to notice on this is these are all classifications based on the angles. There's two ways you can classify triangles. One is by its angles, and the other is by its side lengths. Okay, and so all the ones that we just discussed on this page are all based on the angles of the triangle. What we're going to see on the second page is how do we classify it by its sides. So again, guys, if you do not have this printed out and you are taking your own notes right now, you need to write down these 3 bullet points. But here's the 3 names that we can give a triangle based on its side lengths. So if they are all the same, right? So if you have all congruent sides, then we would call it an equilateral triangle. If 2 of the sides are the same, then we call it an isosceles triangle. That's this guy right here. If none of the sides are the same, then we call it a scalene triangle. So those are the 3 names that we're going to give it just based on the side lengths. So here's a few that they already have done for you. Again, if you're doing your own notes, you do need to write down these 3 examples. But let's just talk about these guys. So right here, when I see that 2 of the sides are the same, right, 2 of the sides are congruent, we can call this an isosceles triangle. When I look at the drawing for this guy, we can see that all 3 are the same. So we would give this the name of equilateral triangle. You might have noticed in the definition of isosceles, the definition is at least 2 of the sides are congruent. So you'll notice this fits that description. So again, we could also identify this as being isosceles, but it's kind of like the idea with the equiangular triangle. We can be more specific than that. So if all 3 are the same, again, it's not wrong to say this is isosceles. However, because we can be more specific than that, we want to be as specific as possible. So we want to go as far as saying it is equilateral to identify all 3 are the same. If I look at these, I can see by the numbers that all of those side lengths are different. So it has no congruent sides. So here's the special name for that, which is a scalene triangle. All right, so let me jump down to these guys. And again, guys, if you're doing your own notes on your own piece of paper, then I do want you to write these down and follow along here with the video. So you need to draw the triangle, and then you can name it for what it is. So as I look at number 1, we can see based on the side lengths that all of my sides are different. And so we would see that as a scalene triangle. Let me just throw a side note in here, because I'm going to mention this on a few of these guys. Usually when we are asked to classify triangles, we're usually asked to classify it by its angles and its sides, right? We worked on the angles on the first half of this lesson. We're now working on the side lengths in the second half of the lesson, but typically you're going to be asked to do both, right? They want to know, how do you classify it by its angles and its sides? So there's usually 2 names that we can give a triangle, right? One of the names is based on the side lengths, and then the other name is based on the angles. So let me just for example, let me throw in some angles on this. So if I were to tell you that this is a 30, 60, 90 degree triangle, then the other name that we could give this is based on the 90 that I have right here, that is a 9. We would also see this as a right triangle, right? So really the 2 names that I could give this is I would look at this triangle and I'd say this is a scalene right triangle, right? We could give it a name based on its sides, and we could give it a name based on its angles, right? So I want to make sure we're kind of hanging on to both those ideas as we go through. I'm going to do the same thing on this one. First thing that we notice right off the bat is, of course, all the sides are the same. So just based on the side lengths, this is an equilateral triangle. However, and one thing that we're going to see as we move forward through this chapter is, if all the sides are the same, guess what has to be true about all the angles? All the angles have to be the same. So if this is an equilateral triangle, then automatically it will also be an equiangular triangle. So the 2 names that we could give to classify this would be equilateral based on the sides and equiangular based on the angles. So we could name it both. Let's take a look at this guy. We can see all the sides are different again. So this would be a scalene triangle based on the side lengths. And let me just do this one more time. If I throw in some angles for these values, let's call this I'm just making these up, so 50, 60, 70. So if I knew that those were the angles of the triangle, what other name could I give this? Right? We know it's an acute triangle based on the angles because they are all acute angles. So the 2 names I could give this triangle would be an acute scalene triangle. All right. Let's jump down to this. Again, going back to just the sides idea. So based on the side lengths, seeing that 2 of these are the same, we can identify this guy as an isosceles triangle. Same thing with this one, right? So just because I'm recognizing that based on those terms that I can see they are equal to each other. Therefore, this again is another isosceles triangle. I'm going to abbreviate this time. All right, and then one more, of course, we're going to see this as equilateral because all the sides are the same. And then again, don't forget the rule that I mentioned here. If all the sides are the same, then automatically all the angles are going to be the same as well. They're all going to be 60 degrees. And so this is not only equilateral, but it's also equiangular. But if they just say classify it based on the side lengths, then I would just call it equilateral. All right, last couple. Let's do some algebra. So now we're kind of going the other direction. Now they are giving me the description of it, and I need to use that in order to solve for x. Okay, and so a couple things they ask us to do on this one is they say find x and the length of each side. So I want to make sure I come up with all that stuff. So as I look at this one word, that tells me that all three sides are equal. So I can pick any of those two sides. I'm going to pick these two and set them equal to each other. And then I can just solve that little equation for x. So as I subtract 2x over to here, I can see that 2 is x. So we did the first part, which is find x. Now let's do the second part. As I take this value and plug it back in, I know that 3 times 2, of course, is 6. And so remember, guys, if this is equilateral, that means if he is 6, they're all 6. Right? So as I plug 2 back into each one of these, I know that I would get 6 for all those cases. Okay, so I know my side lengths are all 6. And then one last one, we can try this one as well. Guys, again, if you're doing your own notes right now on your own piece of paper, you do need to write down these examples and do the process that we're showing you here, okay? So do make sure that you do draw these out, label that information, and then go through with the process that we're doing here. So this one's going to be very similar. This one they are now telling us is isosceles, which means 2 of the sides are the same. And right here they're telling us which 2 sides are equal. So AB is equal to BC. So that's the way I want to set up my equation for this. So if we complete that one, here's what it will look like.